And now I would like to welcome Robert and Joanna Titus, who are retired professors of geology and biology. Robert from Hartwick College and Joanna from SUNY Dutchess. They are best known in the Catskills for their writings about the geological and ice age histories of our region. They've written hundreds of articles that have appeared in many local newspapers and magazines. They've also written 4 books on the Catskills and Hudson Valley geologic history. Their writings bring the science of our local geology alive for a broad swath of people. And you can follow them on their website or Facebook page, The Catskill Geologist. And I'm going to stop sharing so that they can. And take it away, Robert and Joanna.
It wouldn't be a Zoom presentation if something didn't go wrong right at the beginning. There we go.
Usually it's me forgetting to record, so.
There we are.
Nice work.
Thank you. Well, good afternoon. It's such a pleasure to be with you today, even if it's only online. Our talk is about the Ice Age history of Columbia County, with a focus on public preserves, of course, including yours. And this is the Titus publishing empire. He wrote that, I didn't. We live across the river and we publish a lot over there. So right now we write for 3 newspapers and 3 magazines. And one of those newspapers is the Columbia paper. We've also in the past published more than 300 articles in the Register Star. So we know the Hudson Valley geology well, especially its Ice Age history. We've worked with your conservancy several times, and we certainly respect what you do and what you've accomplished. We've also had a long-term close relationship with the Woodstock Land Conservancy. Columbia County's long played an important role in the history of Ice Age science. I'm sure most of you know that one of the earliest fossils in North America, a Mastodon tooth, which is on your screen, was discovered in Claverack in 1705. It was first described as coming from a monster, a biblical giant. People feared its appearance since they had no concept of extinction, and they were expecting more giants to come and possibly do damage to them. But fears were calmed, as the story goes, by an enslaved man who identified it as an elephant tooth, something he had seen when he was in Africa. Dinosaurs and other fossils, along with the concept of extinction, would come much later. Well, let's get to the Ice Age. This is the Laurentide Ice Sheet, as big as Antarctica is today, at the height of the Ice Age, some 20,000 years ago. Most people don't realize just how big it was. And not only large in area, but throughout most of its expanse, more than 2 miles thick. So much ice that it lowered the oceans by about 400 feet. Our part of it originated in Labrador. It snowed a lot up there. The snow piled up. It was compressed into ice, and gravity pushed down on it and caused that ice to spread in all directions, including south toward us. It overran the Hudson Valley, and it didn't stop until it reached today's Long Island. As the ice was pushed south, it crushed forests and parts of mountains beneath it, carrying all that debris from sand to boulders the size of trucks with it. Long Island is essentially a heap of sediment bulldozed there by the advancing ice. So what are some things we find left behind as evidence? First, some things to look for in your local bedrock. These are glacial striations. The advancing ice carries a lot of sand in cobbles and boulders, and the sand planes off the bedrock, and the cobbles and boulders leave scratches called striations. Here, the glaciers moved from the lower left to the upper right. We would like you to go visit the Catskills if you get a chance. And if you do, to go to North-South Lake Campground, just across the river in Greene County. You can see these striations on the shore of the lake. And once again, the glacier moved away from us, and it also carved the lake basin. These are what we call chatter marks. When a boulder is dragged along, it can be pressed into the bedrock by the weight of the ice and get temporarily stuck. Then, when pushed hard enough from behind, it can suddenly leap forward. And when it lands, it produces a fracture, a chip. And it does it again and again and again. And this series of impacts are called chatter marks. You've probably walked across striations and chatter marks many times, but didn't know it. Now you'll notice them. This is a LiDAR image of Mount Marino and Church Hill in Western Columbia County. These bedrock hills were sculpted by passing ice. It actually streamlined those hills. Can you imagine the force of such a thing? There's a lot to learn, and it concerns what we see in the landscape that we all hold so dear. This is the view south from Olana, painter Frederick Church's home, a view courtesy of the Ice Age.
Now, an important question is, yeah, an important question is, how far did the glacier get? And this is a busy illustration, but the yellow line is something, the yellow line is something that we call a terminal moraine. The glacier quite literally came out of the north and got as far as you see with the yellow line. A terminal moraine marks the zenith, absolutely as far as the glacier ever got. Now, we're going to come back to the slide later. We have so much there to explain. For the moment, here is Raritan Bay, and here is Sandy Hook, to give you an idea where that belongs in the real world. Now, this is a diagrammatic view of a receding glacier. It advanced as far as that green line right there. The climate then began to warm up, and the glacier began to melt back. It doesn't retreat, it melts back. There is a big difference between the two. It leaves that heap of sand and gravel and boulders that we call the moraine. And beyond that, we see a sheet of sand, nice clean quartz sand, which we call the outwash. Now, that's just the beginning of the retreat of the glaciers. This map, in some ways, is a better representation of the terminal moraine, the red line at the bottom. Here's Long Island, here's Sandy Hook, here's the New York City area, and here is the Hudson River. What you have to understand, and I'm sure you already do, is that the climate warms and cools and warms and cools, and warms and cools and warms and cools. During the retreat, during the recession of a glaciation, warming causes the glacier to melt back quite a bit. Then typically when it cools down again, it advances only a certain amount. You like to say it's 2 steps back, 1 step forward. And so here's the terminal moraine, the red line. 2 steps back brought it here, 1 step forward brought it to this line, 2 steps back, 1 step forward, 2 steps back, 1 step forward. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 recessional moraines. 11 times the glacier re-advanced to the south until the climate warmed up and it began yet another retreat. Now, the most important recessional moraine is this one right here. If you look carefully, you'll see the letters RH, that's Red Hook, a town within your Columbia County. The recessional moraine passed right through Red Hook and continued off to the northwest. This is complex, but it's important. 2 steps forward, 2 steps backwards, 1 step forward. Retreat, the recession of a great glacier. Now go down to Red Hook on Route 9 sometime, and then turn east on Route 199, go about a mile, and then stop and get out and look to the north. You see an absolute classic example of a moraine. Typically, moraines are hillocks, 1, 2, 3, 4, 5 of these hillocks, and swales in between. We call these cames and kettles, cames and kettles, cames and kettles. And you couldn't find a nicer one anywhere. This view of the Red Hook moraine is as good as they get. In the foreground is the outwash plain. If you went up there with a shovel and dug a little bit, you would dig easily into sand. It's none of this 2 rocks for every dirt in this vicinity. It's all of it sand. So if you get a chance, if you're on Route 199, about a mile east of Red Hook, please look for this. It's a fabulous example of a recessional moraine. Again, as so many times we'll say in our presentation, you're going to see things that you had passed so many times in the past, had never been aware of. We want this talk, this PowerPoint presentation, to train your eye, to make you aware of things that were always there, but you didn't know about. I would like you in your mind's eye to stand here, look to the north, see the moraine, and in your mind's eye, 300, 400, 500 feet of ice rising above this surface. You have to use your imagination to do that. You can and you will. What a wonderful thing it is to be able to do. Now, let's go back to this map once again.
Robert,
Yeah.
just before you move on, we did have a question about over what period of time did the glacier retreat over those 11 times that you mentioned?
I think we can do
About
just
8,000 years.
a little bit. I think we can give you exactly. Why isn't this? It wouldn't be a PowerPoint. There it is.
What?
Help me. Go back. Maybe 2 slides.
I don't.
There we go. One more. There is the Red Hook moraine. 17,900 years ago, the estimate was when this map was put together. Probably the estimate has changed. Let's call it 18,000 years ago. Now, to help you out, this is the terminal moraine. This is the Palisades across the river from New York City, and this is the Hudson River today. But look at all that blue. Those are glacial lakes. You see, what happened is the glacier has retreated. The ice is melting. The ice is flowing south away from the melting glacier, and it's being dammed by the terminal moraine. This is Lake Flushing. This is Lake Hackensack. Lake Flushing submerged virtually all of New York City. When you're in New York City again, I'd like you to look up several hundred feet into the sky above you, about halfway up the great tall skyscrapers that are before you. And that's how far the water of Lake Flushing reached. I'd like you to look at the Statue of Liberty and see the arm of liberty, the head and the arm of liberty rising above the waters of Lake Flushing. It's a wonderful thing to do, and it's real. It's science. That's how far up the lake waters rose way back then. It gets better. The glacier retreats to the north 100 or so miles, and a lake backs up behind it. It's got a name. It's called Glacial Lake Albany. The next time you are in Albany, we would like you to look around and notice that Albany is not San Francisco. Albany is flat. Albany is as flat as a pancake. There's a reason for that. Albany is built on the floor of a lake, Lake Albany, and the bottoms of lakes are flat, always extremely flat. When you're driving down the thruway, you're going to be within Lake Albany much of the way. We'd like you to be aware of that and to notice
Notice what?
Go back one.
Down here.
Yeah. And to notice the flat that you see, golly, it wouldn't be. It wouldn't be.
You want to go forward?
I want to go backwards. We've done this before, I promise you. Yeah. We want you, when you're driving down the thruway in this area, look for and hope to see flat. And when you do, to be aware that that is the bottom of the lake. Forward. Now, in your Columbia County, we especially want you to call your attention to this map. The gray on the map is the western third of Columbia County, and that is the landscape that was drowned, submerged in the waters of Lake Albany. I think both Route 9 and Rhine G will take you south across the floor of that lake. And again, we want you to be aware of this. This isn't very exciting, is it? It's a flat landscape. This picture was taken from the New York Thruway. We were driving north. Joanna said, stop. And we pulled over, and there it was. I know, I didn't hammer. Joanna said, stop! And I slammed on the brakes. We got out, and we took this picture. We were standing along the edge of the thruway, looking at flat. Flat just shouldn't be very exciting, should it? This is not the Grand Canyon, is it? But in this case, flat is exciting. We looked up about 60 feet into the air above us. It was high noon, and we saw the waves going by. 60 feet up was the water level of Lake Albany. The sun was shining through the waves that were passing above us. We're a little bit goofy when we do things like this, but it's marvelous. We see the world as it was so long ago. We see the world as it was way back then, and we see so much that other people don't. You can do this. You can do this anytime you're in the western fringe of Columbia County and you're standing on a flat surface on the floor of Lake Albany. Now, it's rare that you get to see the sediments of Lake Albany, but here they are. We were in Saugerties on the nature trail at Saugerties one day, and they had just had a landslide. And a big crack opened up, the land slid in front of it, and there they were. The sediments of Lake Albany. Almost all of that is clay. It's mixed with silt. It's gloppy, sticky, viscous stuff. It's hard to dig. It's so stiff. It's sediment. It's not hard. It's not rock, but it's stiff. And there it was. We were looking at the sediments of Lake Albany, and we had the good sense to take a picture. I'm not sure we've seen sediments since that day, and that was 15, 20 years ago. Well, these lake sediments are important. They are the foundation of the brick industry, which, of course, as you know, scores of brick factories line the Hudson River up and down the Hudson River from all the way down at New York City to well north of Columbia County. There is a perfectly fine Hudson Valley brick. This is lake bottom. This is lake sediment. It's been cooked. It's been baked. It's been turned into a brick. I don't know if you knew that. The reason we had a brick industry is because we had Lake Albany and the sediments of Lake Albany. Now, Over and over and over again, we keep telling you that we go places and we see into the past. Have you been to the Thomas Cole home in Catskill? It's right there, the red X on this map. Downtown Catskill is right here. Here's Catskill Creek. Here is the Hudson River. Right about there is Olana. Well, we go to Thomas Cole Mansion frequently. We're members at Thomas Cole. We enjoy going to their lectures. And when we go there, we always go out onto the west-facing porch, and we look into the town of Catskill and beyond towards Catskill Creek. But in our mind's eye, we're just 30 feet above the waves of Glacial Lake Albany. The blue on this map is Lake Albany, which has risen above the Hudson River, swelled up Catskill Creek, all the way past Jefferson Heights. We want you, when you're at Cedar Grove the next time, to do just what we do every time we go. Stand on the west porch, look down 30 feet, and see spread out in front of you Glacial Lake Albany. What an experience it is to be able to do that. And aren't you glad you're listening? Now, we're going to join your group on June 18th. And we're going to take a tour of, what's it, Glenmont, I think, Greenport, Glenmont, whatever, the preserve that you have out there. Greenport. And here is the entrance to that preserve. We'll meet, I guess, right here, I suppose, is the deal. And I will be standing, I'll be dressed up as Indiana Jones, which is what I do for these field trips, with my Indiana Jones hat. And I'll be standing there and I will wave my arm high up into the air. And I will do just what I did before. I will say, look up 60 feet. It's noon, 14,500 years ago. The wind is blowing from the west and it's driving waves across the surface of the lake that's up there. The sun is shining through those waves and we're watching them pass above us. We are standing on the floor of Glacial Lake Albany. You've been there. Every one of you has been there, haven't you? Did you know that? Had anybody told you that? Isn't that marvelous? Isn't that wonderful? I think it is. I've been a geologist since I was 5 years old. We're going to walk out to the escarpment that overlooks the Hudson Valley, and you have such a beautiful view. And that's what drew you there. That's why you went there the last time. That's why you've been there every single time. But you never asked the question, how come that escarpment is there? Isn't it pretty? Look at the Catskills in the distance. Look at the Hudson River flowing below us. And you never said, I wonder how this escarpment got there. Well, we're about to tell you. When the glacier towered above us, 3, 4, 5, 6,000 feet of ice rose above us 20,000 years ago, the weight of that ice pressed the crust down 300-400 feet. Remember, Joanna told you that the sea level was 300 feet lower than it is, 400 feet lower than it is today. When that crust was pressed down hundreds of feet, Lake Albany was deposited. The sediments that are beneath us, when I took this picture, were several hundred feet lower than they are today. The glacier melted back and the crust rose. We took the weight off of this mass of crust and it rose hundreds of feet. As it did so, the Hudson River eroded downwards into the lake deposits and created this escarpment, this beautiful escarpment. You didn't know that, did you? Now you don't have to go on the trip in June. Let's look at something else that happens in the Hudson Valley, thanks to Glacial Lake Albany. This is Schenectady, and long ago, 14,000 years ago, the Mohawk River flowed into Lake Albany. And what do rivers do when they flow into a lake? They deposit a delta. And this delta is come to be called the Schenectady Delta. It's a great heap of sand, which forms a plateau that Schenectady is built upon. Hundreds of years ago, settlers arrived. They came up the Hudson Valley. They climbed up onto this plateau. They dug into it and they found sand. They said, we're 20, 30 feet above the river. We'll never be flooded. And because this is all sand, we'll be able to dig basements. Let's build our house here. Let's put our house right here. It's a wonderful place for a house. The next family came, built their house, the third, the fourth, the fifth. What do you know? Over a period of time, Schenectady came into existence. And nobody knows it, and probably hardly anybody knows it today. But that city is built upon an ice age delta, a delta of Lake Albany. When we go to Schenectady, we notice once again, it's flat. It ain't San Francisco. It's flat. It's the top of a delta. Now, a lot of that sand blew off to the west, off to the east, and created the dunes of pine bush. Pine bush, as you probably do know, represents a whole bunch of old sand dunes just east of the Schenectady Delta. When the lake drained, the wind blew across the delta, it blew the sand to where Pine Bush is today. When you go to Pine Bush, stand on top of one of those dunes, look to the west, look up and around you and see the lake, and then look to the west and imagine the delta. Now, you have a delta a lot closer. I did this picture. And it's called the Elizaville Delta. And it's where a river flowed into Glacial Lake Albany and deposited the sands of a delta. It's much smaller than the one that Schenectady is built on. That's why Elizaville isn't very big. Now let's learn about deltas. If you took a good earth science course in high school or in college, you learn this. At the top of a delta are flat-lying sands. They're called the topset beds. The front of a delta is strata, sediments, deposited at a relatively steep angle. Beyond that are the foreset beds, and then the bottom set beds. The bottom set beds are the lake deposits. The foreset beds have the incline to them, and the top set beds are flat. This is your standard model delta. It doesn't take long to remember this one. You've just learned a little science, and it's going to be very hard to forget, will it? Now, if you travel to Elizaville and you take, I think this is Route 10, County Route 10, you'll drive north on it, and you will look and you'll see a lovely slope to your right, to the east, and you'll see a flat surface to the west, to the left. If you've been on this road, you paid no attention whatsoever. You didn't understand what was right in front of you. To the right is the foreset of the Elizaville Delta. To the left of the highway is the bottom of Lake Albany. The lake rose to the very top of the delta, which is right up here. What a wonderful thing it is to see. When we first saw this, we were almost ecstatic. I said, look, that's a foreset. Look, that's the bottom of the lake. We were excited. We were jumping up and down, happy as could be. Oh, right, I'm exaggerating. We snapped a picture and on we went. Having made a marvelous discovery, we didn't make the discovery, other people, geologists had been there before us, but maybe you'll get a chance to drive on this highway and maybe you'll stop and see what's right there. Now, we were exploring the area. We got real interested in Elizaville, and Joanna yelled, "Stop!" And she pointed in this direction, and we saw a sand pit. Now, we could have said sand pit, that's nice, good place to see sand, but what did we see? Can you see it? Take a good look. Let's point the arrow right there. I hope you can see the arrow. Look at that. Those are strata which are inclined. That is the foreset of the Elizaville Delta. What should be above the foreset? The top set and top set strata should be horizontal. Down at the bottom are the lake deposits, the bottom set, they should be silts and clays. This just looks finer grained, looks silty and clay. This looks like sand, this looks like sand. This is an absolutely fabulous cross-section of the Elizaville Delta. In all the years I've been a geologist, I've never seen a better example of delta deposits than this one right there. We can only hope you can still see it. The problem with these sand pits is that foliage grows over them very quickly, and this may be invisible now, but we had the good sense to take a good picture, and this is in our book. Okay, now we're gonna learn you a little more that you didn't know before. Every single one of you has been to Hyde Park. I'll bet every single one of you has been to the Roosevelt Mansion and the Vanderbilt Mansion. And I'll bet you've been down there for concerts and to tour the homes. And I bet you've walked some of the trails and had a good old time. You've driven through Hyde Park. What you didn't know is that the entire town of Hyde Park is a delta, a glacial Lake Albany delta. Crum Elbow Creek flowed into Lake Albany right there and deposited all of this sand into the delta, actually two deltas. The yellow delta is the older of the two. It's the it's the Roosevelt Mansion delta, and then this is the Vanderbilt Mansion delta. You didn't know that Hyde Park was a delta during the Ice Age. Now, again, when you're there the next time, we want you to pay attention to how flat Hyde Park is. It ain't San Francisco. You've never paid attention to that before, but now you do pay attention to it. When you go to the Vanderbilt Mansion, you'll probably park right here. And when you're parked at the top of the top set and you're
Robert?
looking, yeah.
We're still seeing the Elizaville slide.
Oh, no.
Okay, let me see if I can, I was trying to tell him that. Oops.
Okay. Looks like it's getting worse.
Okay, we'll have to skim down.
Yeah, you can do it right there. How many times have I said it wouldn't be a PowerPoint presentation?
Still not doing it. Stop.
And stop.
Oh yeah, I was gonna say, yeah, what is that? Resume slideshow. Oh, there we go.
Okay,
Yeah, but
it still says
we have to
that
go back.
we're, okay, no,
We have to go back and show them Hyde Park. No, backwards, the other way, the other way. There we go. This is a map of Hyde Park. You can all see it now, I hope.
don't,
Okay.
Yes, we can.
Yes, and I have to. The Hyde Park is flat, and it's a delta. Crum Elbow Creek to the upper right flowed into Glacial Lake Albany along the green-yellow boundary and deposited that delta. Now, here you're parking at the Vanderbilt Mansion. You're at the mansion and the parking lot are at the top of the top set, the top of the delta. We're looking over the edge at the foreset, down the slope of the foreset, and out there in the distance is the bottom set. Now, you've all been to the Roosevelt Mansion, Springwood, and I bet every single one of you stood exactly at this spot. And look, even now, you've learned just a little bit, but now all of a sudden, you've learned something that you never knew before. Springwood stands upon the top set of the Hyde Park Delta. Before it is the steep slope of the foreset, and a little bit further to the left, out of view, is the bottom of Lake Albany. We always like to say that when you're on the top of a delta, you're in knee-deep water. When we are walking around in that lawn, we take ourselves back in time. We're walking around in knee-deep water at the top of the Hyde Park Delta. Go there the next time you're at Springwood. Stand right where we took this picture. Remember that you're standing on a delta, an ice age delta, and appreciate what you see that you had never seen before. Next. Oh, it's your turn. Let me go back to Joanna now.
Thank you.
You're welcome.
About 13,300, yes, 13,300. That's according to the scientists at Woods Hole. Years ago, something extraordinary happened. The ice was well on its way, melting back up to Canada, but it had formed, as it sometimes does, a plug, what we call an ice dam, at the northern tip of the Adirondacks, blocking meltwater to the north and to the west. And that meltwater had formed a glacial lake, a very large glacial lake, about 3 times the size of today's Lake Ontario. And it was called Lake Iroquois. And sorry, but it's spelled wrong here, and that's
Woods Hole. Yeah. Great scientist, poor
Can't
spellers.
spell. Well, one day, that ice dam melted just a bit too much, and all that water came flooding down the Hudson Valley, about 13,000 cubic kilometers of water. That's a lot of water. When it reached the terminal moraine across the Verrazano Narrows in New York Harbor, it blew right through that terminal moraine, kept going across the land exposed by the low oceans, and flowed off the continental shelf. It formed the Hudson Shelf Canyon, which is this big long thing you see. And it still is a prominent underwater feature today. A lot of people go there and go fishing because the water does something for fish. I don't know. It also is rumored that it turned Staten Island into an island. And a cold period followed this event. Whether or not the flood disturbed the ocean currents and caused the cold period is still being discussed in scientific circles. But whatever the cause, there was a cold period of several thousand years called the Younger Dryas, when the ice once again readvanced. Maybe this is the final readvance, and we think that the final readvance causes geologic features that are called drumlins. And these are numerous small hills, mostly found within and throughout Western Columbia County. This is a German drumlin at Germantown, right off of Route 9, with a steep northern end to the right and a gently sloped southern end to the left, a shape almost like an upside down spoon. Notice in the foreground the flat surface. This is the bottom of Glacial Lake Albany. And even if you look closely, you're not going to find any rocks or even little cobbles, because this is all the sediments of Lake Albany and all sands and clays. This is the top of a drumlin, the crest of a drumlin. And this is off of 9G on Cemetery Road. And the cemetery actually occupies the top of the drumlin. And also notice that the sides of a drumlin are symmetrical to the left and right. Another LiDAR image, and this is an image that is of a drumlin field. So all these little bumps are drumlins. And drumlins often come in big groups like this. And back to this picture that you've seen before, all of the dots, the black dots on this drawing are drumlins. So this is a drumlin field that's located in Western Columbia County. And in Claverack, another drumlin field. And you can go and see them. The roads go up and down over the tops of the drumlins. And typically in between, there are wetland areas. The water kind of gets stuck there. So let's go back to Robert and the drainage of the lake.
Okay. Let's go forward a little bit. There we go. You're standing at the very top of Bash Bish Canyon. I have such a hard time saying Bash Bish. Who named that? And it's a classic V-shaped valley. Bash Bish Creek is down there at the bottom, and it has eroded. It has carved the V shape, very narrow at the bottom, typical of very intense erosion. The creek has flowed out of western Massachusetts and into the Hudson Valley and done a real good job of creating this canyon. We can't look at something like this without thinking of raging, foaming, pounding, thundering whitewater torrents cascading out of the hills above and into the valley below. Is this? Yes, it works. I think I can do that better. And then at the bottom of that canyon, you get to Bash Bish Falls. And it's usually a real disappointment. It isn't Niagara, is it? It doesn't roar. Great masses of white water aren't pouring across the lip of the falls. It's usually a real, well, it's pretty. It's not disappointing, but you'd think it could do better. It doesn't match. The canyon and the waterfalls don't match the flow of the water here. We have to conjure up an image at the end of the Ice Age when the Laurentide Ice Sheet in western Massachusetts was in full melt, when the climate was warming up very quickly and the ice was being converted into meltwater. And that's when the raging, foaming, pounding, thundering whitewater torrents created the landscape that we see, the beautiful landscape that we see. We searched the web and we found this photograph from Alaska, I believe today, and it gives you a better idea of what Bash Bish Falls might have looked like at the time that we're speaking. And it's a better explanation for how the canyon, the V-shaped canyon you see, and the waterfalls came into existence. Now on the right is Bash Bish Canyon. The falls, I think, are just a little bit off the map. And we see that it flows out onto the valley floor below. On the far left is the Roloff Jansen Creek. Bash Bish Creek is a tributary of Roloff Jansen Creek. Bash Bish Creek, many think, is a better source for the Roloff Jansen Creek. This map shows the narrow canyon entering into a much broader valley, and it conjures up something that my wife and I, Joanna and I, have been debating for, the last 20 years, really. It is our opinion that the glaciers melted from the top down. in that the hills of western Massachusetts witnessed the melting of the glacier, the Laurentide Ice Sheet, while the valley floor was still filled with ice. We want you to conjure up an image of Bash Bish Falls being in the tunnel of a whitewater stream at the bottom of the glacier. Bash Bish Creek flowed through a tunnel down the canyon out onto the floor of this valley, where it joined the tunnel of the Roloff-Jansen Kill. And they two combined streams flowed off to the southwest through a tunnel at the bottom of a glacier that filled the Roloff-Jansen Kill Valley. What a marvelous thing it is to conjure up that image. Let's go back and see the raging, foaming, stream passing through a tunnel right there. Look up if there's enough light to see. You'll see the walls of the tunnel, the top of the tunnel. What a marvelous image that is. Now we go down a little bit further and to the lower southwest part of this map. And there it is. It's flat, isn't it? And you're all thinking it's the bottom of a lake. And we've been lying to you. Here's another image. It's even flatter. This is the valley of the Roloff-Jansen Kill. It's a broad, flat surface. You go, okay, if it's not the bottom of a lake, it must be a floodplain, right? We've lied to you again. The credibility of science is withering right in front of you. This is an outwash. If you paid real close attention before, you saw that when a glacier retreats from a moraine, that a sheet of sand is deposited in front of it. And that's what you have here. If this was the bottom of a lake, you would go out onto that field with a soil auger, you would drill into it, and you would get sticky, clayey, silty lake sediments. You don't. You get sand. You get nice, pure, clean sand, an outwash deposit. Well, what did it look like? What did this stretch of the valley look like at the end of the Ice Age, about 12,000 years ago, when the glacier had melted away and even the valley floor was had melted its glacier? There is what fiddlesticks. There is what that looked like way back. It's so hard. That's what that looked like way back when. These are called a braided stream. A braided stream is called a braided stream because there's many channels and they go back and forth past each other like the braids of hair in a woman's ponytail. That's a braided stream, and all that light-colored stuff is sand and gravel. There is a glut of sediment, far more sediment than the little bit of water can handle, and that creates a braided stream, and the braided stream creates a sandy plain, which after the water drains away completely, will look like the Rojan Creek looks. We continue to the southwest on the Rojan Creek Valley, and we are approaching one of your preserves, the Drowned Lands Preserve. And there it is. We took this picture one day when we were exploring years ago. The Drowned Lands are awfully well named. They're named the Drowned Lands because they are lands that have been drowned in standing water. There are ponds, there are marshes, there are swamps. There are a lot of, there are what?
Bogs.
Bogs, yes, you're right, there are bogs. It's a wetland, it's a big fat wetland. And, but what did it look like further back in time? It looked like this. I don't know where this picture came from. We found it online, but it could have been the Drowned Lands as they were, about 12,000 years ago. You see, the Rojan Valley was blocked by heaps of sand, which had been left behind by the melting glacier. And those heaps of sand dammed the valley. And if you think there are a lot of ponds there now, there were many more of them back then, and they were all bigger than they are today. Well, when you go to the Drowned Lands Preserve, we know that you're going to see this, but what we want you to do is to see that. We want you to stand in one location and occupy 2 moments of time at the very same instant. The past, the geologic ice age past, and the modern day world as it is today. Now, if you go past the Drowned Lands, you pick up the Rolf Jansen Kill. It's called the Rojan Kill. The cat is trying to help out. And it's cut a canyon across the floor of Lake Albany. The white area to the right of the canyon and the white area to the left of the canyon is the valley floor, but it's also the bottom of Lake Albany. And remember what I told you before, when the glacier melted off of this landscape, the weight was removed from this landscape, and the landscape went, and rose. It rose 100 feet or maybe even 200 feet. The Rolf Jansen Kill was forced to erode a canyon across the bottom of glacial Lake Albany. Here is where the Rolf Jansen Kill enters the Hudson River. And here is a beautiful view of that canyon. Right here, it's actually cut into black shales, which are beneath the lake deposits. You've seen this canyon 100 times. You've driven across that bridge 100 times. You never asked how it got there. The crust was depressed by the weight of the ice. And then when the ice melted, the crust rose and the river cut into it. Now, why is he showing us a picture of Niagara Falls? Because I bet most all of you recognize what this map is communicating. In the year 1678, Niagara Falls was out there in the distance. By 1764, it had retreated. It had eroded back 1819, 1842, 2011. Excuse me, Professor Titus, why are you wasting our time with this view of Niagara Falls? Here's where it gets better. Niagara Falls in the upper right, the Canadian Falls, is at the end of about 10 miles of canyon. At the very bottom, you see the Niagara Escarpment. The falls used to be there. The Erie River tumbled off the escarpment right in the foreground and has eroded its way about 14 miles, I believe, and continues to erode where it is today and will continue on into the future. The day will come when the falls will work its way all the way up to Lake Erie, and all of Lake Erie will drain down the river, and all of Lake Erie will be emptied. None of us will live that long. We won't see that, but it'll be very exciting. But excuse me, Professor Titus, why are we getting a lecture about Niagara Falls and its retreat? The next picture may help you out a great deal. It was taken at one of your preserves, the High Falls Canyon. And at the head of the canyon, at the top of the canyon, is High Falls itself. Niagara Falls is at the upper reach of the Niagara Canyon. High Falls is at the upper reach of the High Falls Canyon. High Falls, like Niagara Falls, has been and continues to retreat. You didn't know that when you went there the last time, did you? And you will know it the next time. Walk up the trail in the canyon, look to your right, look to your left, and appreciate that, like the Niagara Falls, it's a product of waterfall recession. It's just one of those exciting things. You have to know a little of the geology to appreciate, to understand. Okay. We're going to go back to Joanna, where she's going to talk about some of the negatives in our story, some of the bad news.
Thanks.
I leave her to do the bad stuff.
This is a map of landslide hazards in New York State. Each color represents a different landslide hazard, with, as you might have guessed, the red areas being the worst. You can see the hazards up and down the Hudson Valley, but what causes those hazards? Well, here we are back to the sediments of Glacial Lake Albany. You can see, if you look, the close relationship between the lake and the landslides, and the lake and the landslides. And it is those lake deposits that we keep talking about that cause those landslides. The silty, sticky sediments that might make great bricks, but they're also very dangerous. And they can be very unstable. We showed you the layers of the sediments a couple slides back. And when they become waterlogged, they tend to let go. Those layers of clay make for very slippery surfaces, especially when they're very wet from winter melt or from heavy rains. I have to admit that I once slid all the way down a hill and crashed, actually literally crashed into the carriage house at Wilderstein in Dutchess County on a rather wet day, sliding on top of those sediments. And there have been over 100 landslides in Columbia County over about as many years. And one of the newest ones you might have heard about was along Claverack Creek in Greenport. And that was at the Italian American Club.
Young Italian Americans.
Yeah. And
We predicted it.
Yeah, we did. And this is one, pretty much larger one, that happened one day in Delmar. And Delmar is on the western side of Lake Albany. Same sediment buildup, and it was after several days of heavy rain. That curved, steep back wall is typical of a lake sediment slide. And that's the worst of the sediments of Glacial Lake Albany. Well, we hope that despite the hazards we've shown you, that you will come to look on Columbia County and the greater Hudson Valley and the Catskills the way we do, as a gift of the Ice Age. And we thank you for listening.
We'd be very happy to try to answer any questions that you might have. Heidi, did we get some questions?
You
Great.
did, yes. So I don't know if it's too hard, but so someone asked, you talked about drumlins, but are there any Roche Montagnais? I don't know what that says. You can look in, I think you have access to the chat, or hanging valleys to see in the area. Karen, if you want to come off mute and ask your question, feel free.
A Roche Montagnais is pretty much the same as a drumlin. It's the French word. I think it means sheep back in French. I'm not absolutely sure.
Okay.
What was the other
yes.
part?
So I was, this is Karen Reek. Hi.
Hi.
Yeah, I wanted to know, drumlins are primarily sedimentary deposits, but are roches montagnais primarily rock that has been shaped by passing glaciers? And if I have that definition right, are there any of those in the area to see?
Church Hill, we think, is a rock drumlin.
Yeah, Mount Marino, even a better one.
Yeah. So there are some around here, yes.
And then I also asked about Eskers and hanging valleys.
You
I was a little optimistic with the hanging valleys.
The hard ones. I always get the hard ones. Okay. What was the first one?
Eskers.
Oh, okay. Oh, well, you don't have any Eskers that we know about in Columbia County. At the bottom of a glacier, a melting glacier, you can have a stream, a subglacial stream. We think you did have those. A subglacial stream will deposit sediment just like any stream. And but it's at the bottom of a glacier. So when the glacier melts away, the stream deposit rises above the floodplain surface, which you don't see at Copay. We'll have to see if we can find something there. And so a esker is shaped like a river. It's the deposits of a river, but it rises above the floodplain. We have some very nice ones in the Catskills, but I cannot take you anywhere in Columbia County and point one out there. A hanging valley is a alpine feature when you have a big glacier flowing down a big valley, and a little glacier, a little tributary glacier enters it from a small perched valley. Then you get a hanging valley. Oh God, without a photograph, this is very difficult to define. But hanging valley is way up above the main valley. And that's the best I can do without a photograph. Sorry. Hate tough questions. Hate them.
All right, so this
I'm
one I think
sorry,
will be a
you-
little. Oh, go ahead.
Was there another question?
Yeah, we have a couple of more. So this one I think is easier. Have you been able to travel to see an actual glacier?
We don't want to admit to this, do we?
No.
No. We have
No
never
comment?
seen, neither one of us has ever seen a glacier.
In person.
Yeah. Stephen Crane didn't serve in the Civil War. He wrote the Red Badge of Courage. We never saw a glacier. We wrote the Ice Age, Hudson Valley in the Ice Age. Stephen Crane gets us off on this.
Okay. Now we have one here. Do you have a more detailed map of the eastern edge of Lake Albany in Columbia County?
It's disappointing to find the mapping of Lake Albany in the literature. It's hard to find good published maps. And the two maps that we showed you, the one of the Schenectady Delta and the other of Catskill, are as good as they get.
Yeah.
And the funny thing is, it's real easy to determine the elevation of the lake shore, and then to take a standard topographic map and draw it in. I think probably the question was like, where can we go see a good map? And I don't know. We haven't found one. You probably can't either.
We usually kind of make our own as we go along.
Yeah. If we're going to be working in Hyde Park, we get the map out and we draw in the lakeshore. It's easy to do.
Okay. Is there still glacial melt flowing from the north?
There is a small area in Labrador that is still the original ice from the last ice age. So I guess you could say that it's still melting to a certain degree, but generally speaking, no. But the Greenland ice sheet, was that's still there,
It's not part of the Laurentide technically. It's melting.
but it's, yeah. So there is melt going on, but from the last ice age directly, probably not.
Okay. And do any of your articles or books address the northern edge of Columbia County, specifically the area around Malden Bridge, Kinderhook Creek? And thanks for the fabulous talk.
We published one in the Columbia paper
About Kinderhook Creek.
a couple years ago. Yeah, the Martin Van Buren house is outwash. And if you go to Martin Van Buren house, it's flat and it's glacial outwash, I think is how we interpreted it. And Kinderhook, the town of Kinderhook is built upon an Ice Age delta. You'd have to have a good map. I don't know if we've written 1,000 articles. We can be forgiven if we don't remember the details. I think
Maybe that's something we should go and do in the spring and write an article in the Columbia.
Yeah, maybe we can.
So are all of your articles that you have written on your blog?
No, we're
Not all of
working,
them,
we've
no.
done about 250 of them.
Okay.
We publish them every week. And so we've got another 3 years worth. And by then we'll have published a whole lot more.
Great. Okay, are there any other questions?
We look forward to meeting some of you in person on June 18th at 10 in the morning at the Greenport Preserve. Should be fun. And so that'll be nice. It'll be
Yeah,
nice.
so we will have that up on our website probably on Monday, with all the details. And like I said, we'll send a link to this video. And there was one more question that came in, well, two more. One asking if your cat is also a geologist.
Biologist.
No, yeah. Mm.
And then about 12 years ago, you published a series on the Rojan. Are those articles available?
Somewhere.
Eventually?
We could publish them on our blog.
Yeah.
Most of our readers are on our side of the Hudson. So yeah, our blog is Facebook, the Catskill. Oh, no. thecatskillgeologist.com will get us to our blog. And yeah, maybe we could, there's 7 articles. Maybe we could publish them over the span of 7 weeks. And then you could see them. But other than that, no, our book though covers most of that material. And there are several chapters in our book, the Hudson Valley and the Ice Age, which would pretty much cover everything that we did in those articles. If you have a library that has those old Columbia County independent newspapers in it, you might be, I don't remember even which year it was a long time ago.
Your register store.
Yeah, we had a lot of fun. We went to Bash Bish Canyon. We picked up the Rojan there and we drove all the way down to where it entered into the Hudson River, and we wrote 7 articles. The river has 7 different personalities. So it's not the Mississippi River, but it's a pretty darn interesting river. I'll see if we can get going on those in our blog site. Yeah.
Yeah, and Elaine had another question of where at the Hudson? So I think she's asking, where does it go into the Hudson? The Rojan? Is that right, Elaine?
Just above Germantown, right?
Germantown. That's what I was going to say too. Yeah.
North of Germantown.
South of Alana.
It's a big bridge. You drop down into a valley and you cross a big
Yeah,
bridge.
you can't miss it. It's a really big hill.
Yeah.
If you're on 9G, it's
Yeah.
Yep.
all right. Well, last call for questions. This has been so interesting. I'm definitely going to look at areas much differently now, and
Especially after you buy our book.
well, exactly, and go on your field trip on June 18th.
For everyone, if you have something you have a question about, or you have a strange rock that you want identified, please take a picture of it with your cell phone, which takes fantastic pictures actually, and email us, put the picture on our Facebook page, and we'll try our best to tell you what it is.
I'm so excited to know that. I found a rock in my garden that I will do that.
There
There
you
you
go.
All right, well, so this is our last nature night for the season, and we're so grateful that everybody attended, and look for the email with all of the links and stuff that we talked about tonight, as well as a link to other events that we have coming up. And we look forward to seeing you out on the trails. And thanks so much, Robert and Joanna. This has been great.
Thank you for having us.
We've enjoyed it.
Thank you.
Good night,
It
folks.
was a great